Lesson 2-2, solving one-step equations. So to solve an equation, this means that you're finding the value of the variable that makes the equation true. So your ultimate goal is to get the variable alone. To get the variable by itself. When you get the variable by itself, then you have therefore solved for the variable. So we're going to look at the addition property of equality. So if an equation is true and the same number is added to each side of the equation, the resulting equivalent equation is also true. That should be the word the. For any real number a, b, and c, if a equals b, then ac plus equals bc. So what this means is that whatever is on one side of the equation has to be equal to the other side. So it has to be balanced, is a word that I often use with the equation, so you may hear it. It must be balanced. It's like a scale. Whatever's on one side has to be on the other. So let's look at this example, solving with addition. So we currently have c minus 22 equals 45. Our goal is to get the variable c by itself. Well, to do that, you have to get rid of whatever's happening to it. So right now, we are subtracting 22. To move anything across an equal sign, you have to do the opposite of what's happening, and then it will move it to the other side. So if we're subtracting 22 now, we can add 22 to this side. That makes these two go away, because if you think of it on a number line, if you go to negative 22 and then you add 22, then that would end you back at 0. So now this is over here is c minus 0, so you could actually just make that go away, and it can just be c equals, and then you add 22 to this side. So 54 plus 22 is going to give you 76 as your final answer. To check this, you go back and you plug in your answer for your variable. So 76 minus 22, and we know that this is 54, and it should be equal on both sides for it to check out. Pause the video to try a few examples. Solve by adding. Let's look at the first example. 113 equals g minus 25. So again, we're trying to get our variable by itself. So whatever's happening to the variable, you do the opposite. Well, right now it's subtracting 25, so we're going to add 25 to both sides. By adding 25 to this side, it goes away, and it just leaves us with g. And if we add 25 to the other side, we get 138. So we assume that g is 138. If you plug it in to the other side, you would have 138 minus 25 is 113. So you would say that those are balanced because what's on one side is the other, so it's equal. J minus 87 equals negative 3. Again, you're solving for your variable. You're going to add 87 to both sides, so this one goes away. We're going to add 87 to this side. Now, remember that when you're adding negatives, you got to really pay attention. So in this case, if we added 87 to a negative 3, we're actually going to get a positive 84. So now, if you try to plug this in, 84 minus 87 needs to equal negative 3. Well, negative 3 it does. So you have negative 3, and it checks out. Your answer here is 84. Your answer for the first one should have been 138. We can also solve equations by using subtraction. So if any equation is true, the same number subtracted from each side, the resulting equation is equivalent, so it would make it true. Looking at the example below, 27 plus k equals 30. I'm sure that if I asked anybody in the class what plus 27 is 30, you could tell me the answer. but I want you to learn this process because as we continue to work through and we move on to multiple steps or equations with variables on both sides, this can become a little bit tricky. So it's very important that you learn the foundation and the process, and as we grow and build on it, it will become a little bit easier because you've already learned that basis and you've learned the foundation. So here you again have to look and see what's happening to the variable, and it's addition. So we do the opposite. So we're actually going to subtract 27 from this side. Whatever you do to one side, you do to the other. So you're going to subtract 27 over here. 30 minus 27 is 3. So K equals 3. So you can plug that back in and it should equal, so 27 plus 3 should equal 30, and it does, so it would check out. So your answer would be 3. Pause the video to try the few examples below. 18 plus D equals 42. So you identify the variable and you identify what's happening to it. We're adding 18, so that means that we subtract 18 from both sides. So 18 over here, so D would equal, and now you have to figure out what 42 subtracting 18 would be, and you would get 24, so D would equal 24. If you go back in and plug that in, 18 plus 24 equals 42, and it was expected to equal 42, so you would say it checks out. The next example, the variable is H, and you're adding, so you're going to subtract 447. So if we subtract 447 from the other side, when we have two negatives, we know that's the same as adding them together and keeping the sign. So this is actually H equals 704. And you plug that back in, set 447 plus a negative 704. This would be something you could enter into a calculator. You would get 257, which is what you were trying to get, so it would check out. We can also solve equations with multiplication and division. This is very similar to the previous one. You know, anytime that you are multiplying or dividing a variable, you do the opposite. Multiplication is opposite of division. So if an equation is true and each side is multiplied by the same non-zero number, the resulting equation is equivalent. And so AC equals BC, or A over C equals B over C. So since this is following the same pattern as addition and subtraction, I want you to try these few examples on your own. So pause the video and try these examples. So negative 75 equals negative 15. So again, you have to ask yourself, what is happening to my variable? And you're multiplying it by negative 15. So to do the opposite, you have to divide by negative 15. So that one goes away, and you divide the other side. Anytime that you are dividing negatives, the negative sign, if it's two negatives, a negative divided by a negative is a positive. So this one would be B equals 5. And if you plugged that in, negative 15 times B would get you 5. Down below, this one's a little bit trickier because you're actually multiplying by a fraction. And to do the opposite, you divide by a fraction. But we can't divide fractions, so you actually have to multiply it by its opposite. So you multiply this side by 5 over 3 and it goes away. So you multiply this side by 5 over 3. With fractions, you can multiply straight across. So we get 30 divided by 3. So K equals 10. Now if you go back and you plug this in, if you had a calculator, you could plug in 3/5 times 10 and you would get 6. So pause the video to complete the lesson review. Make sure that you're showing all of your work. Sometimes this can be a little bit tricky. Always remember that whatever's happening to the variable, you do the opposite to cancel it out. Whatever you do to one side, you must do to the other.